Hai, Assalamualaikum warahmatullahi wabarakatuh to my panel, Dr. Rashid and Cik Afizi. So today, myself is Cik Muhammad Najmi bin Cik Muhammad Amil from the MMA 21. I want to present my final year project, which is evaluation of material failure model in radius to roof resistance test FMVSS 216. And my supervisor is Cik Khairul Amri bin Tofawat. So before we go further, I want to tell about my presentation outline. So first I have background project, and second problem statement, third objective, and I have scope, literature review, methodology, simulation project, result and discussion, and conclusion. Okay, so for my background project, the main research is to find the material failure model which is near to the actual test. Then when we get the material failure model near to the actual test, it will cut the cost of the test. So what is material failure? Okay, the material failure is a breakdown of an object such as metal, concrete or plastic due to various factors that affect the strength, stability and chemical composition of the object structure. And what the causes of material failure? The causes of material failure is incorrect material selection, incorrect processing, incorrect manufacturing procedures, inadequate design or incorrect use. Okay, so this is my problem statement for my project. So the current FA model has error in strength to weight ratio, which is SWR, is 5.41 compared to the actual test result, which is SWR 4.10. And want to find the right material failure to get close to the actual test data. So this is my objective. First is to simulate the material failure model comparable to the actual resistance test according to FMVSS 216 within 20% of error. And the second objective is to compare the strength to weight ratio SWR result between current FE model and updated material failure model. Okay, so this is my scope. First, I use Hypercrash and Hyperview software to do a simulation. And second, I setting the parameter at by quad material failure model properties. And the third is focus on critical part which are surrounding and impacted contact of refrigerant test. So I go to the literature review. So rollover are the most serious and dangerous crashes among all type of traffic crashes. The most vulnerable to rollover crash are head and neck injuries. Rollover have complex dynamic event and like other traffic accident consist the vehicle, human and environmental element and their interaction. And rear roof crash test has been widely used to evaluate the safety integration of vehicle structure where there are specific standards such as FMVSS 208 and FMVSS 216. A quasi-static simulation of roof remain the most difficult of this simulation. So there you can see this is a frontal structure. Core principle of structure design for crashworthiness is to preset a crumpled zone which can absorb vehicle kinetic energy during crashes. Okay, this you can see the side structure. You can see that B pillar at bottom can get padding. Okay, side impact has the chances of upper limb injury are greater than in frontal impact. The door beam should therefore be stiff enough to take the load on. The B pillar also take up the load in case of side barrier effect. Okay, so what is SWR actually? Okay, SWR is the strength to weight ratio. SWR is actually one of the way to measure the strength of vehicle roof. The strength weight ratio SWR allows you to evaluate material of varying mass or situation where resistance to braking is present, such as in construction. So the greatest SWR value for the most applied force within the 5 inches of platform journey distance is the maximum SWR value of those SWR peak values. So the SWR peak concerns the maximum strength of the vehicle roof structure against crushing and hence represent the roof strength. So that you can see that is the actually the formula of SWR, which is maximum applied force divided by unloaded vehicle weight. Okay, so actually this is the some type of material failure in radius. I have Johnson Cook, backward, and third one. Actually, all these material failure has their own characteristic, and in my final project, I choose backward for my material failure. Okay, for my meteorology, for sure I use hyper crash and hyper view to run project and to get the graph, the data. And model selection, I have Chevrolet Silverado 2014, get from CCSA website. So then the run simulation, of course, I want to compare the SWR result with the actual test, which is 4.10, and want to improve material failure model parameter in the current FA model to get the percentage error below 20% from the actual test. Okay, so we go to the material failure model parameter. Okay, so actually material failure I choose by quad in this material. So material that I choose to change the material failure is at BH210340. Why I choose BH210340? This because that you can see the material at BH20340 consists the at critical part of the roof test. You can see the roof and the door is at the roof test. So actually, what is BH 20340? BH is means big hardening. 20340 means the tensile stress. Okay, so the parameter that I've changed in this bicod material failure is material for selector flag. I choose predefined for mild steel, which is 210 and 340 is a range of mild steel. And flag for specific behavior, I choose plain strain in global minimum plus localized necking. And the instability start value for localized necking actually you can see this is simple that you can call is n value. So where I can get this n value is at the characteristic from BH20340. Okay, so this is the next material failure model that I've changed in material HSLA. What it means HSLA is high, strong, low alloy. Okay, that you can see 500 is in range of HSS steel. Okay, so the end stability for this is 0.12. The pattern of the parameter is same like previous method that I've tell. So this the third material film model I have changed in the material of HF1050 HF mean hot form. So same like the previous, but this change to UHSS still because the range tensile stress 1050 is between USS still. And the end value that you can see is 0.07. So same like this, the material that I've changed at material MS, which is MS means the martensitic steel. Okay, this the value that I've changed is same like like HF because the value of tensile stress is in range USS steel. So I choose the end value is 0.07. Okay, this is my simulation project video. Okay, so result and discussion. Okay, so this is my result. So this the first result when I don't change anything parameter, I don't change the material failure parameter in this model, then I get the result that you can see. The peak value is 123,929 Newton and at time 0.1195 second. Okay, actually this far from the actual test because you can see the percentage error is 31.5 to for peak force and 31.22 for strength to weight ratio. Actually, the strength to weight ratio for this simulation is 5.38 after I calculate the SWR. So we go to the next one is okay, this is my after I update the material failure, after I change the material failure to bipod and I get the actually the positive result and closest to the actual test result. Okay, so that you can see the peak force is 113,028 Newton and the time 0.1136 second. So actually you can see can see that I get the SWR for this simulation is 4.91, which is the percentage error of this SWR is 19.76%. So it means it's close and it's below 20%. So actually I have achieved my target for this final year project. Okay, so that we can you can see that this is the actual test result simulation from IIHS, which means Insurance Institute for Highway Safety. And you can see the graph for the actual test is it can get 4.10. The actual test is for the SWR, and the peak force is 94.231 kilonewton. Okay, actually you can see that use Chevrolet Silverado as a model for actual test roof resistant. Okay, for the actually this is the summary lah, summary for my analysis of comparison. That you can see that actual test is 94.231 kilonewton, and for the data when I don't change anything material, it get 123.929 kilonewton, and after that, after I change the material, it get 113.028 kilonewton, which means after I change the material failure model, it get the closest, the more closest to the actual test. That you can see the percentage error for this default parameter and the after I change the material failure, it's is quite big different. And actually after I update the material failure, it's get more good data. Then you can see at the SWR. SWR is actual test is 4.10 and at default material 5.38, and after that I change the material failure using bipod material failure, it can get 4.91, which is the percentage error for after I update the material failure model, get the 19.76 percent, which is below 20%. Actually I have achieved my objective for this. Okay, lastly we go to the conclusion. So to simulate the material failure model comparable to the actual roof resistance test according to FMBSS 216, within 20% of the error has been achieved based on the analysis using hyperwork. That means I get the SWR is below than 20%, which is 19.76%. So the comparison of strength to weight ratio result between current FE model and updated material failure model has been achieved and been approved that the updated material failure model has good rating of 4, which is great based on roof strength rating boundaries. Okay, I think that's all for me. Thank you.